Right, let's start to discuss from the tutorial of the last day. Uh, that is about regression, correlation, and chi-square test. So the first question is, below is a sample data set for the heights and weights of 10 men, heights 69, 70, 65 likewise. Uh, then weights are 192, it is give 148 likewise. So the first one is draw a scatter plot for the above data. Use SPSS to generate model summary, ANOVA, and coefficients. Interpret the regression output and determine whether height significantly predict the weight. Okay, so first we have to uh, enter uh, the data into the data set SPSS. So you can see here there are two variables. One is height, the other one is the weight. So both are numeric variables, both are scale variables. So we can define these two variables first. Then in data view, we can enter this data. 69, 70, 65, 102, 148, 140 likewise. Then we need to draw a scatter plot. You know how to draw a scatter plot. Graphs, legacy dialogues, scatter. Then a simple scatter plot. So you know x-axis we can take as height, y-axis weight. Then we can take this output. Right. This is the output graph. So here, actually you can see that if you observe the shape of the graph, we can see here, there is a positive correlation, right? It is not very strong, right? But uh, I think if you observe this, the shape of the graph, you can see that is approximately moderate positive correlation. So we cannot exactly predict by you looking into the diagram, right? Anyhow, that you use if we look into the scatter plot, we can see uh, there is a positive correlation, but it is not a linear relationship. It means a strong positive correlation. Anyhow, there is a positive correlation. So we can uh, exactly write the conclusion by looking into the correlation coefficient. So we need to calculate it. So then by observing this scatter plot, we can see there is a positive correlation. Right. Then secondly, uh, we know we can use the regression. So analysis, general analysis, regression, linear, linear regression. So we can take dependent variable weight, independent variable is height, right? So what we need to take as the outputs, uh, model summary, ANOVA and coefficients, right? So we can take descriptives if we need, right? Um, and yes, options, right? We'll take the output. Yeah. So we can take these outputs, right? Uh, model summary is there. Model summary is there. Uh, model summary. ANOVA is there. Okay. They are asking about the model summary, ANOVA and coefficients. Coefficients. This is there. And other than that, so we have descriptive statistics also, because I requested the descriptive statistics. You can see here the mean of the weights equals 176.7 and mean of height is 69. And the standard deviation also we can see here. Then if we looking into the correlation, so you can see in previous, sorry, here if you looking into the scatter plot, we saw that there is a positive correlation. So we in here we can take the value Yeah, that is 0.86. Actually, it is a strong positive correlation, but it is not perfect positive because it's not it's exactly a straight line. Anyhow, that it is closer to straight line because you need to approximate this is 0.9. Therefore, it is strong positive correlation. Right. Then when it's come to the model summary, so R square value is very much important. Here also you can see this R value. It is again like this correlation, same correlation value here. Zero here correlation is 0.86. Right. Then here also you can see in the model summary 0.86. Right. So R square value is very much important here because R square is it is like a effect size measure. It means how much the percentage of the independent variables predicted by uh, the dependent variable. In here, you can see that is 0.74. If you wrote this as a percentage, that is 74%. Then therefore, 74% of the independent variable is predicted by the dependent variable. Therefore, uh, actually, to be a good model, this value should be greater than 80%. It means 0.8. But this is not, this one is closer to 0.8. Therefore, actually, this model we can use to uh, predict the dependent variables actually because but this is not a very good model because if to be a very good model this value should be greater than 80% or 0.8. Then here it is closer to 0.8. Therefore we can use this model to predict the dependent variable. So it means independent variable is predicted by the dependent variable 74%. When it's come to the ANOVA table, so you can see that is significant, right? Because then regression is and residual, those things are given. So if we consider the coefficients, so you can see here the coefficients. Uh, uh, yeah, the height is this is and it is significant because that is less than 0.05, and these values are significant. So we need the constant values here. Um, yeah, coefficients. Uh, this is we can write the regression equations. Regression equation that is dependent variable is weight equals. So I will show you how to write the regression variable. Then by using these values. So here you can see this is the output, right? I think you can write by looking into here. The dependent variable is weight. So therefore we can write weight equals then this is the constant value negative 241.793 plus uh, then the coefficient is uh, sorry, gradient is 8.848 times independent variables, that is weight. Sorry, height is the independent variable, right? Height is the independent variable. So therefore we can write this is our regression equation. Weight equals negative 441.793 plus 8.848 height. It means if we know any heights, we can calculate the weight. For an example, suppose height is, so we need to predict the weight of a person. If the height of that person is, so we'll see the mean value to take the value. So height of that person is, mean value is 176. So I will take the height as 150 centimeters. So if that height is 150 inches, sorry, 150 inches or centimeters, I don't know what is given there. 150, sorry, inches, 69. So I will take the height as 60 inches, right? Height. Then we can calculate weight of that person. Then how? By using the regression equation, weight equals negative 441.793 plus 8.848 times. Now what is the weight? 60. So then we can predict the weight of that person weight equals to, then we can calculate the weight of that person. So we can, yeah, can use the calculator for that. Right. We can use the calculator. Right. Then negative 441.793 plus 8.848 into 60. Then the weight is 89.89.087. 89.087. Right. Likewise, we can calculate the weight of a person by using this regression equation. So that's why we are using these models, because if you know the independent variable, so we can calculate the dependent variable by substituting the values, right? So therefore, the prediction purposes, we can use these regression equations, right? So that is for the first one. Then second one, a chicken farm owner has a feed supplement to increase egg production. The data set consists of 12 groups of 100 chicken each receiving different supplement levels. This is the data. Group 1 to 12 and feed supplement and number of eggs. Draw a scatter plot for this one, for the feed supplement and number of eggs. Okay, we'll draw. So, right, first we have right. So we have to enter the data. So therefore, we have to define these three variables: group, feed, supplement, and number of eggs. Then we can enter this data. So and so next one, draw a scatter plot. Draw a scatter plot. Um, right. Draw a scatter plot. Then you have to do a regression analysis to find the relationship. So then therefore, number of eggs we can predict by feed supplement by using this model, right? So using this model. So that's why we are using this regression analysis. So then how we can do is, the first we need to draw a scatter plot to see the relationship. So therefore, graphs, legacy dialogues, scatter plot. So the simple scatter, then y-axis is the dependent variable, that is number of eggs. Then x-axis, independent variable, feed supplement. Yeah, so this one is, then if you observe this one, so that is not just, we can see a very good linear relationship. Then this is quite spread. So you can see here that the correlation is not strong here, right? Like the previous question, because it is stronger than this one. Okay, so then we can go for the regression analysis, yeah, regression, linear regression. So number of eggs is the dependent variable, independent variable is this one. Then we can go, so statistics, so you can take descriptive statistics if needed. Yes, I will take it. Then, okay. So then here, mean number of eggs is 87.48, feed supplement 17.5, that is the mean. And yeah, Pearson correlation. So we can see here that is actually 0 point feed supplemented number of eggs. That is 0 point feed supplemented number of eggs. Yes. feed supplement, and number of eggs. That is 0.499. That is means approximately 0.05. 0.5. So it means there is not a very strong correlation between that two. Then when it's come to the model summary, you can see here again R square value is 0.249, that is 24.9. So what is the meaning is here? Actually, this is not a good model because 24.9% of the independent variable is predicted the dependent variable. So therefore, actually, this is not a very good model to predict the values because this R square value is not greater than 80% of 0.8. So if it is greater than 0.8, only we can use to predict the dependent variable because that is a very good model. Then here the model is not good, right? So because this R square value is not greater than 0.8. Anyhow, so when it's come to the ANOVA table, you can see 0.09. Actually, this is not a significant model because this is greater than 0.05. Anyhow, that so we can find the regression equation. So that is you can write dependent variables number of x equals to um, 77.267 plus 0.58 feed supplement. So that is the regression equation here. So by using that, so you can predict. But remember that so here R square value is not greater than 0.8. Therefore, this is not a good model to predict the dependent variable. Anyhow, that you can predict the values, but we can't guarantee this is exactly correct because of this model, the strength of the model. Here you can see the model is not good actually. Uh, right. Then third one, a psychology student examined the long-term effects of alcohol on reaction time by measuring response time and self-reported alcohol consumption per week. So alcohol consumption units given here and reaction time is also given there. So, yeah, draw a scatter plot, compute the Pearson and Spearman correlation coefficients, interpret the correlation results, explain whether alcohol consumption significantly affect reaction time. So then here we have to use the regression, right? Correlation. Correlation and they are in the question, so we have to find whether any relationship between the alcohol reaction and alcohol consumption and the reaction time, right? Okay, so we can draw a like scatter plot. Question number 3. Mm, Question number 3. Here we can see consumption and time, so we can enter this data. Then we can go. We have to draw the scatter plot first. Yes, draw a scatter plot. So therefore, what we can do here is graphs, legacy dialogues, scatter plot, simple scatter. Then dependent variable we can take reaction time, independent alcohol consumption. Yeah. So here you can see there is a positive correlation here actually. So if alcohol, yeah, that is actually reaction time in milliseconds. So then you can see here positive correlation. And then if we compare to this one, yeah, that is actually stronger than this one. But yeah, so we can find the value also. Then we can go to calculate, interpret, uh, yes, analyze, correlate by variable. So because we need to find the correlation, alcohol consumption and reaction time. So it's mentioned that find both Spearman and Pearson correlations, right? Pearson and correlation. So then, okay. So then we can find the correlations. Yeah. Yes, you can see here the reaction time and the alcohol consumption that is 0.805. So therefore, Yeah, significant correlation we can see here because the value is less than 0.05, then it's flagged and it is mentioned correlation is significant. Right? And so that is the Pearson correlation, that is parametric correlations. So then and here it is mentioned uh, to calculate the non-parametric correlations also, you can see here, there is the non-parametric, that is PMN's value. This is Pearson value, that is quite similar actually. Then here value is 0.809, 805, this value is 0.809, that is quite similar. Again, so you know this the difference between this Pearson's and PMN correlation. So Pearson's correlation is for the parametric data, which means data from the normal distribution. So, but this PMN correlation, so we can use any data. It may be parametric or non-parametric. But so you remember that. So Pearson correlation is stronger than the PMN correlation. So if the data is normally distributed or the data from a parametric distribution, so it is better to use the Pearson's correlation because that is stronger than PMN correlations. Anyhow, that your data is not normally distributed or the data are categorical data, so you can use non-parametric correlations by using this PMN's correlation. Right. This is about multiple regression, I think. Yes. Yes, yeah, it's many things to calculate. Right. We'll see one by one. The data set below examines how the study habits, sleep duration, and exercise routine influence students' academic performance. Therefore, the dependent variable is academic performance, is mean exam score. And these three are independent variables. So not then this is multiple linear regression means one independent dependent variable and three independent variables. Your study hours, sleep hours, and exercise hours. Right. So we need to calculate how it is predict the study hours, sleep hours, and exercise hours, how predict the exam score for student. Therefore, three independent variable and one dependent variable. Uh, yeah, it is designed for multiple linear regression analysis to explore predictive relationships among these variables. This dataset examines the relationship between students' study habits, sleep patterns, and exercise routines and their exam performance. The score is measured out of 100. Yeah, this is the data, right? So, okay. So then first thing is we need to enter this data, right? We have to enter this data. We'll see question number 4. So firstly, we have to enter this data to the SPSS worksheet. So this is study hours, sleep hours, exercise hours, and exam score. So all the things are here now. Then what we need to do is first calculate mean, median, and standard deviation for study hours, sleep hours. Yeah. So then it means they're asking descriptive statistic, analyze descriptives, descriptive statistics, then options, mean, median, what we need to find, uh, calculate mean, median, and standard deviation. It is not mentioned here, so therefore we can go mean, median, standard deviation, analyze descriptive statistics, frequencies, then statistics. Yeah, so we need to find mean, median, and standard deviation for this, right? Then for this all uh, sleep hours, study hours, yes, for all, four, right? Okay. So then we can find these things, mean, median, standard deviation, everything for this too. So you observe the value, so mean of the study hours 5.55, mean of the sleep hours 6.5, exercise hours 2.15, and the exam score is 87.20. These are the means and the medians also here, then standard deviations here. That you need to do the first. That's the first, you need to find the descriptive statistics in the first question. Second one, compute the correlation coefficient between study hours, sleep hours, exercise hours, everything. So you need to one by one. So you need to calculate the correlation coefficient, right? So then we can go analyze, correlate, bivariate. So we need to calculate all correlations. Yeah, analyze, correlate, bivariate. Then okay. So I'm going to calculate Pearson correlation here. Yeah, these are the correlation matrix, right? Correlation matrix. If you're looking at to here, so you need um, so study hours and sleep hours. That is negatively correlate. Yes, that's okay now. So if this number of study hours increased, so the number of sleep hours decreased. So number of sleep hours decreased, increased, then number of study hours decreased. That it has a negative correlation, right? And exercise hours also negative correlation. Exam score, yes, there is a positive correlation. It means number of study hours increased. Yeah, exam score is also increasing. Here it is mentioned here. So you can see here the 0.583. Not a strong positive correlation. Anyhow, that it is positively correlated. Then when it's come to the sleep hours and the exam score, you can see again there is not a significant correlation. Significant correlation. So you need it is flagged. If it is significant, it is flagged. These two are significant correlations. Only two of these we can take. Exam score and the study hours, and also exam score and the sleep hours. We can't find any uh, significant correlation between exercise hours and the study hours. Right. Perform a multiple linear regression with the exam score as the dependent variable and study hours, sleep hours, and exercise hours as the independent variables. So then we can go for analyze, regression, linear. Then the dependent variable is exam score. Independent variables, there are three independent variables now to here. Then we can take the out. Yeah, we can see the output. Mm, then we can see the correlation is 0.7494, uh, and the model summary R square 63%. That's R square value is 0.63. Therefore, 63% of the dependent variable, 63% of the independent variable is predicted the dependent variable. It is not a very bad model, but it is not a very good model also. That is actually, so if to be a very good model, that should be greater than 0.8 here. But we can use for to do the predictions. Then ANOVA table is there, so it's very significant. So you can see here. And so the most important one is the coefficient table. So then here we can actually um, we can create an equation here. So right, you can see the equation looking to the output, right? Our dependent variable is exam score. So therefore we can write exam score is equals what? Exam score is equals to constant 53.043 plus, it is mentioned here 53.043 plus, these are the intercepts 3.177, 3.117. Then what is the variable? 3.117 study hours plus the other uh, gradient is 2.121 sleep hours. 2.121 sleep hours. Plus the other variable is exercise 1.433. 1.433 exercise hours. right? Now, if you know these three of any person, so study hours, sleep hours, and exercise hours by using this equation, actually, this is an equation, this is the regression equation we found. By using this, you can calculate the exam score of a person, right, of a student. So we can predict the exam score if you know these things, right? I think you can understand why we are using this regression formula, because that is by using these regression models we can predict uh, the dependent variable, right? Right, the regression equation, okay, we wrote which predictive variable has the most significant impact of the score, right? Which one is most significant? This one, because that is, because you can see the coefficient. So then here 3.117, it means this is multiplied by 3. Then what the variable has the most significant effect? Study hours. Therefore, if we increase the study hours, we can increase the exam score. That is actually normal behavior. So therefore, here mathematically we can prove that. If any predictor variables are insignificant in this model, yes, justify your answer using the p-values. Yes, yes, we saw that. Uh, yeah. So here, this is a constant is significant. Study hour significant because zero point 0.0, it is less than zero point 0. And see, this one. So exercise hours, that is not significant. Why? This is greater than 0.05. Other than exercise hours, because these are less than 0.05, this is greater than 0.05, this is not significant. Therefore, for here we can see any predictor variables insignificant, yes, because exercise hours insignificant in this model because the p-value is greater than 0.05. What is the r square value of the model? What does it indicates? I explained that at the beginning. The r square value is 0.630. That means it is indicates 63% of the independent variables predicted the dependent variables. Only 63%, because then it is not a very bad model and it is not a very good model to predict the values, right? Based on the regression model, predict the exam score of the student who studies 6 hours, right? So we can predict, right? So we have to predict exam score of a exam score actually, right? Exam score of a student in 53.043 as constant. Then study 6 hours per day, 3.117. Now multiplied by 6. Why? Because that student is studies 6 hours per day, right? Then we need to multiply by 6. And next one is 2.11121 multiplied by sleep 7 hours per day, then multiplied by 7 because sleep hours is there, plus and 1.433, 1.433, and exercises 3 hours per day. Then we know everything. Then we can predict the exam score. Example equals to, then we have to use the calculator. Uh, right, exam score equals 53.043 plus 3.117 multiplied by 6 plus 2.1121 multiplied by 7 plus 1.433 multiplied by 3. Yeah. The score is 90%. The score is 90.891. It is approximately equals to 91. So then if we know the independent variable, then marks of that students is 91, because you know how, why is that? Because now we constructed a model, then we know the independent variable that a person, that students is studies 6 hours per day, sleep 7 hours per day, and exercises 3 hours per day. So then if we know these independent variables, so by using this constructed model, constructed regression equation, so we can find, we can predict the dependent variable. Here the dependent variable is the exam score. Now I think you have the clear understanding about what is regression model, and why we are doing this regression analysis, how we can predict the dependent variable using these independent variables. Okay, based on your findings, what advice you give to the students want to improve their performance? Yeah, so what is the advice means that, so we need to increase all of these things actually, because we need to study more hours, and also we have to balance, we need to sleep also that better hours, then because this person is studies 6 hours per day, sleep 7 hours per day, and exercises 3 hours per day, then he scored 91, right? Discuss how the lifestyle factors can be balanced, maximize learning outcomes. So we need to balance everything, so then we can maximize these learning outcomes. Right. So there are some more actually. Then here for this chi-square test, this one, right? Okay, now we discuss about the correlation and regression analysis. These questions to the chi-square test. Right. The following table represent the gender, job type, random sample of supermarket. So then we can enter this data to the worksheet. So you can see here job type. Job type is supervisor, self checker, till operator, cleaner. So here I decided job type. I assign to the numbers, 1 for supervisor, 2 for shelf stacker, 3 for till operator, and 4 for cleaner, right? So that's why here I entered 1, 2, 3, 4, 4. Then because the job type is defined. And also the sex, male, female, here also I decided to use the numbers, 1 for male and 2 for female. Then here in data view, you can see 1, 2 is there, and also the counts. Then here supervisor male supervisor 20. So then here 1 1, that is 20. Likewise, we can enter these counts also. Male supervisor 20, female supervisor 15, shelf stacker male 20. Right. Likewise, I entered the everything here. Right. Okay. Now compute the expected frequency as is no association is perform chi-square test for independence, interpret the result. So conclude whether gender and job type are independent. So we need to, right, we need to calculate actually whether there is a significant relationship between the uh, sex and the job type. Sex and the job type. Right. Therefore, you have to remember that. So we did this last day also. Before performing a chi-square test, we need to do one thing, that is we have to weight the case by count. So weight cases by count. That is the first thing we have to do. Weight cases by count. Now we can go for chi-square test. Analyze. You can go analyze descriptive statistics, cross tabulation, cross tabs. Analyze descriptive statistics, cross tabs. Then rows and columns, you can see here. What are the rows? Rows are job type, columns are male, female, right? So therefore we can enter uh, rows, job type, columns, this. And so what you need here, frequency, chi-square. Yeah, we need to calculate the chi-square here, right? We can go for the statistics, chi-square we need to calculate. Okay, then do we need, okay, chi-square, continue, right? Then we need to see whether we need uh, yeah, yes. Then you can compute the expected frequencies. Yes, we have to compute in cells. And here observed frequencies. Okay, then it is mentioned that calculate the expected frequencies. Therefore, we have to tick this one also, right? Any other things need? No. Then okay, this is the out. So then this is the chi-square test. So the more then here the expected count is also calculated here, right? So we need uh, this one. So Pearson chi-square test, and you can see that is 0.001. Then it means that is less than 0.05. Then there that means so how we are writing then here we need to calculate job type and sex no. So therefore we can write there is no significant relationship between job type and the sex of a worker. But so and it is rejected. Null hypothesis is rejected because this is less than 0.05. Therefore, actually we can conclude there is a significant relationship between the job type and the sex of a worker, right? Okay, that is about this one. Then last question again, chi-square test. A survey of a supermarket employees recorded their attitudes towards the restraint based on job type. Neutral opposed support. Job type is cashier, cleaner, manager, and stocker. Compute the chi-square statistic using SPSS. Determine whether job type and wage attitudes are associated. Yeah. So then explain there is a significance of the findings. Therefore, we can write first we have to write the null hypothesis. How we can write. So there is no association between job type and the attitudes associated. So that is the null hypothesis. Then the alternative hypothesis is there is a significant difference. There is no, a significant difference between job type and wage attitude. Okay. Right. So then we can enter the data. We can enter the data. Right. This is the data. Uh, this is the data. Job type is here. Job type is mentioned here. Right. For the values. 1 for cashier, 2 for cleaner, 3 for manager, and 4 for stocker. And also the attitude level. Right. Attitudes levels neutral, oppose, and support. Uh, it is assigned to 1, 2, 3. Okay, now that data is here, right? So then again, we have to perform a chi-square test, therefore data, weight cases. So we have to weight cases by count again. Count. That is the first thing you have to do before performing a chi-square test. Right? So you need to weight the cases by the count. Then we can go for the chi-square test as previously. Analyze descriptive statistics, cross steps. Then, yeah, so the columns, the rows are job type rows, columns are wage rate. And then we can go for the statistics, calculate. We need to calculate the chi-square, continue. Then we have to go for the sales. We need to calculate the expected frequencies. Then okay. And this is the output. So you can see the expected values are calculated there. Then when it's go to the chi-square test, you can see here, this is 0.00. It means we have rejected the null hypothesis. There is a significant relationship between the job type and the wage resistance here now. Because the chi-square value is significant, right? So likewise, we can find whether there is a relationship is or not in the categorical variables using this chi-square test, right? So if we are using the categorical variable, so we can't go for the t-test and ANOVA because it is not normally distributed. Therefore, we can go chi-square test to these kind of data. Right. So that is about the tutorial of the previous thing. And this is today's the last session actually. So because we need to actually all the types of tests are completed now. But if we calculated the data from the ground, okay, so then it means suppose you are collecting the data using a questionnaire. So then therefore before using that using to the analysis purpose, so we have to check the validity, reliability of these things. Right. I can move to this next part. Right. Today we are going to discuss about the regression, sorry, reliability analysis and the fact analysis. Right. These are the learning outcomes of the today's lecture. That is, understand the purpose of and the application of the fact analysis, differentiates between principal component analysis and the common fact analysis, perform a principal component analysis in SPSS and interpret the key outputs, apply principal axis factoring and maximum likelihood, use varimaction direct oblique rotation methods, generate and interpret factor scores for the further analysis, apply factor analysis techniques to simplify data and identify key patterns. Other than that, we are discussing how to do the reliability analysis. Actually, so I think you have sound knowledge about the research methodology. So before perform any questionnaire, so you need to check the validity and the reliability. To check the validity, we can use the fact analysis. To check the reliability, we can use the reliability analysis, right? That is cron-patch alpha value. Right. So yes, so actually, this is quite belongs to the research methodology. Anyhow, I am simply explaining you there are two types of variables. One are the observed variables, and the other one is the latent variable. Right? Observed variables means the variables we can directly observe. For an example, if we consider the height, weight, so we can measure those things. Right? Height we can measure using a measuring tape. Weight we can measure using a balance, right? But some variables we cannot be measured directly. For an example, SPSS anxiety. So that is a psychological factor. So we can't measure this variables directly. So the variables cannot be measured directly. We call latent variables. Latent variables. So then to measure the latent variables, there are some scales that is we call some questionnaires actually. So using the standard questionnaires because we need to validate those questionnaires. So then in that questionnaires, there are some questions. Those are the observed variables. By basic using the answers of the observed variables, we can actually find these latent variables. The correlations among all observed variables can be explained by the latent variable. I think you have the idea. So then there are two types of variables, observed variables and latent variables. Observed variables we can take the informations by the participants by you, and latent variables means so By collecting the observed variables using some strategies, actually that's why we are using the fact analysis, how it is, how we need to find how it is connected to this latent variable. So by using these observed variables, then we can calculate this. Sorry, by using these observed variables, we can calculate these latent variables. Right, for an example, one is SPSS insight. If we consider the motivation, again, it is a latent variable, right? So likewise, that's if the psychological context, so sometimes it is very difficult to measure this latent variable directly. For that, we need to use a set of items actually. So there are a set of questions in a questionnaire. So by using that set of questions, so we can find these latent variables. Yeah, so then here I used a simple questionnaire, right? Simple questionnaire to this, and it's SPSS anxiety questions. 8 items there, right? 8 items are there. And using this practical example, so because I have a data set with more than 2,500 participants, right? So I collected that data. By using that data, so we can have a discussion, so how we can do this analysis. This is actually the practical example because I told you at the beginning in this course, we are trying to do a practical example, how to analyze questionnaire, how to enter the data and everything now we discussed. Then I'm going to show you a practical example, so how we can do this, how we can actually test this validity and the reliability. Right. The further 8 questions included in this questionnaire, it is these are the observed variables actually. I dream that Pearson is attacking me with correlation coefficients. I don't understand statistics. I have little experience with computers. All computers hate me. I have never been good at mathematics. My friends are better at statistics than me. Computers are useful only for playing games. I did badly at mathematics at school. Right, these are the 8 questions. It is included in the questionnaire, right? Okay. Then, yes, so we can calculate the correlations, right? Correlations. Uh, yeah, you know how to calculate the correlations. So from everything here, this is the data set, right? This is the data set you can see here. These are the 8 questions, right? 8 questions here is statistics main. Then here, strongly agree to strongly disagree, right? Strongly disagree to strongly agree. 9 is used for not answered, right? Then you can see this data. So yeah, nearly, no, exactly 2,571 entries here, right? 2,571 entries here, okay? Then I enter all the data to the SPSS worksheet. Then first we can calculate. First we can calculate whether there are some correlations. Right. For that we can calculate the correlation matrix. Correlate bivariate, and we can take all of these as variables. Then we can calculate the correlation. This is the output. Right. This is the output. Then here you can see, I think it's clear with this one here, negative 0.99, negative 3, 0.3, 0.337. Likewise, you can see these values, right? These are the values actually. And so in here, I think you can see there is a flag. So then here, everyone, the flag represent it is significant. Its correlation is significant at 0.01 level. That's why it's flagged, right? That's why it's flagged. So when it's come to here, so you can see here uh, these two uh, negative correlation. This one, what is it? Standard deviations excite me, and I never been good at mathematics. Yeah, there is a negative correlation here, large negative one. We can observe large positive one here also. Likewise, we can take general understanding. This exists varying magnitudes of the correlation among variables. We can have general understanding about the correlations, right? So if we did a correlation analysis first, uh, partition partitioning the variance in factor analysis. Common variance, variance that is shared among set of items. Then we can find H square, that is communality, that is common variance, and unique variance, right? Then there are two things, specific variance and error variance. Um, yeah, so then variance participants means principal component analysis, right? There is actually, so H square equals to 1. In principal component analysis, there is no unique variance. Common variance across a set of items make the total variance. Right. So then here you can see this model is we discussed. Then here, these are the observed variables, and this is the latent variable here. Then here you can see uh, the total variance is made common enough to the unique variance. So then this is the model. By using these 8 items, what we are going to do, we are going to measure the SPSS anxiety. So that is the model actually. So these are the observed variables. It means the items in the questionnaire. There are 8 items in our questionnaire. So this is, by using these things, we are going to measure the SPSS anxiety. Yeah. Right. Principal component analysis first, uh, with 8 and 2 components, right? So now we have the 8 variables. We calculated this uh, correlation, right? To replicate the correlation matrix using the set of components that's a fewer number than the original set of items, right? So there are 2 components. So now we are going to divide into two components using this principal component analysis, right? Then you can take some eigenvalues here. So it is calculated, but there are some formula to calculate these things, but SPS is automatically given these things. You need to only interpret these things, right? Total variance is explained by the given principal components, eigenvalues. So we can see whether these eigenvalues are greater than 0, that is good. Negative eigenvalues is ill conditioned. So eigenvalues close to 0 is multicollinearity. Then eigenvectors, right? So these things are need for the interpretation. That's why it is given there. So you need to have some idea about these statements. Eigenvectors, weight of the each eigenvalues, eigenvector times the square root of the eigenvalue is component loadings. The component loadings are the correlation of each with principal component. Eigenvalues are the sum of the square component loadings across the items for each component, right? So you have to know these terms actually, because when we are interpreting the data uh, obtained through the SPSS output, so we have to use these terms, right? Then we can perform the principal component analysis with 8 components, right? So because here it is, we are going to fix these values to the 8. Right. So this is the path actually when we are doing the factor analysis. So actually we are doing the exploratory factor analysis. Here it is mentioned as factor analysis, but we can conduct only exploratory factor analysis using the SPSS. There is another factor analysis called confirmatory factor analysis, but that facility is not in SPSS. So if we need to do the confirmatory factor analysis, we have to go for AMOS, M+ or some other software, right? So in SPSS only have this exploratory factor analysis, right? So we can go the path, analyze, dimension reduction, factor analysis, right? Analysis, dimension reduction, factor analysis. Then you can see this dialog box. In this dialog box, so we need to take each and every variable to the factor analysis. There are 4, right? We can take all these variables to the factor analysis. Yeah, now it's okay. We took all the variables to the fact analysis. Then, yeah, then we can go for method factor extractions. So, method factor extraction method that should be changed as principal components, right? Principal component. Before we can see it is here mentioned principal components. Again, we need no need to change here. And the other one is we need the unrotated factor solution and we need the scree plot as well. Right, then unrotated factor solution, then we have to tick on scree plot as well. So then okay, then extract. So then now we are not going to extract based on the eigenvalues. Here we have fixed factors and we are setting the factors. There are 8 factors, then maximum iterations for convergence should be 100. That is our values. Therefore, we are going to fix number of factors, that is 8. Then we need to change this 400. These are the number of iterations. Then we can press OK. So then this is the output. Then here mentioned communities, total variance explain these things, right? And script plot as well. Then component matrix here. So I entered this the output uh, to the to my presentation. So by based on that values, we can discuss what is represented here. Then here first one is we can see these component loadings. Yeah, this is component loadings actually. You can see 0.659. This out. This is component matrix, right? You can see this component matrix, a correlation of each item with principal component, right? Then you can see here some of that in that theory part I explained you some of squared loading across the components is the community. It means so we need to square this one and square this one, and if we add this one, so we can take this community. And also for this one eigenvalues, it means sum of some squared loadings with down column, that is we call eigenvalue, right? So we have to square this and square this all, and if we need to add these 8 components, so then I add squared and add. So you can see here, so we call this is eigenvalue, right? So then there are two terms, the community and eigenvalues. uh, then if we consider one component here, so if we add this all, we call that is a community, and if we add for downwards, that's we call the eigenvalue. So if we compare, if we use this component loadings, component matrix. Second one is total variance. Total variance explain 8 components in fact analysis. This output, total variance explain. Right, you can see here total variance here 3 point. It is not changed actually. Initial eigenvalues remained as after this extraction, right? Initial eigenvalues, because we didn't use any rotation method here. That's why look family extraction sums of squared loading is equals to the eigenvalues now, right? Yeah, same thing, because we didn't use any rotation method. So then these are the eigenvalues actually, because we calculated these things. These are the eigenvalues, right? These are the eigenvalues. Here you can see these eigenvalues like this. Correct. Initial eigenvalues are like this, and also extraction of the sum of squared values remains same because we didn't use any rotation method. Later on, we are discussing what happens to these eigenvalues, initial eigenvalues, if we use these uh, rotation methods. Right. This is the scree plot. Scree plot. You can see the scree plot. This one. Eigenvalue and the component number. Right. Eigenvalue with the component number, which is called the scree plot. So you can see here. Here this eigenvalue should be greater than 1, that is, and here you can see this elbow from here. Since community of 1, the principal for the single item eigenvalue is greater than 1, right? So then here you can see how it changes. In here you can see this change how. Right. So then we use now 8 components, factors. we extracted to 8 factors first. Now we are going to reduce these factors to 2. Then earlier then because here in factor analysis, right? Then here we took that there are 8 items. We took it as same, right? But in dimension reduction means that we have to reduce the number of factors. So then here earlier the number of factors we used as 8, but it is useless actually because already it is 8. So in the dimension reduction means we have to combine 2 or 3 questions in a questionnaire and take a one variable, right? So then in this factor analysis what we are doing is, so we are finding this which items need to be combined to make the variable, right? That one we can find using this uh, factor analysis, right? Then here then now we can extract for 2 factors actually. Then we can go again the same path, right? Analysis, dimension reduction, factor, then extraction. So now we are going to extract for 2. So I am changing only this 8 for 2. Then we can take the output, right? So this is the output again. We can go for the total variance explained. Total variance explained is here, right? Earlier, so if you remember earlier, so you can see here, all of these values are same. Why? Because we didn't use this dimension reduction. We used all 8 components. Now this is actually initial eigenvalue, so we reduced to 2. Now we have only 2 components because there are 8 components. Using this extraction method we reduce that for the 2, right? So you can see the eigenvalues, and here 3.1, and this only we have 2 extraction by using that extraction method. Notice only 2 eigenvalues. Then if we use the communities table, you can see here the extraction 0.853. Right, then here you can see the extraction method is principal component analysis. Actually, you can see here, if we consider, um, if we add this, right? So actually the 84, like nearly 84% of the total variance, right? Nearly 84% of the total variance is uh, in item 2 explained by compared to 1, right? So that is how we can do this dimension reduction. Right, then we can extract the factors. Then here, first thing is we actually we decided how many factors, right? With previously 8 factors, then I reduced to 2 factors. That is decided by us, right? But actually in the common factor analysis, actually we are not deciding based on the eigenvalues. So we are giving the freedom to the SPSS to design which factors actually we have to combine and make the variables. For that we can use this common factor analysis, like principal axis factoring or the maximum likelihood functions. Right. Factor analysis, actually exploratory factor analysis, I explained you. This goal is to reduce a dimensionality, but assume total variance can be divided into common and unique variances. Make more sense to the defined construct with measurement error. Right. So then here we have the 8 variables, right? 8 variables. So we need to reduce it, right? We need to reduce it. Again, earlier we reduced to 2 factors, but we decided 2 factors. Make eigenvalues will come back. SPSS do not change the menu reflects the changes in analysis. You have to know this in yourself. Then here actually fixed number of factors. We decided it. Actually, we decided is two factors, but we have to give the freedom, as I mentioned a minute ago that now, because we have to give the freedom based on the values, based on the relationships to take which value, which items we need to take together to check the variables. Then that is actually better for the final results, right? Yes. Now, unlike principal component analysis, now we can go for the principal axis factoring actually. Principal axis factoring, it is, yeah. Now, same thing, analysis, um, dimension reduction, fact analysis. Now, extraction method is principal axis factoring. That's all. Then we can take the output, this output actually. So you can see here, this is the output, right? Again, and here again decided to uh, we decided to reduce for two factors actually. So this is the two, right? So what are the earlier values? Yeah, these are the earlier values. Then now we compare to this one, right? So sum of the loading one is 2.51. Second one is then sum of the communities across all item is 3.01. Now here that some of the initial eigenvalues do not equal to some of the squared loadings here, like principal component analysis. Now if you use the principal axis factoring, it is not equal. And you can find the sum of the eigenvalues here also 4.124, right? Okay, so that again that we use that actually. We use again here we decided I need two factors. This decision is taken by us. I told you we have give the freedom to the SPSS. Therefore, we can extract based on the eigenvalues. That is decided by the SPSS. So we have to command to do that. Yeah. So then now we decided we give the freedom to the SPSS. Okay, to decide. So how we can collect the items in a questionnaire to make the variables. Therefore, we can go analyze dimension reduction, again fact analysis, um, extraction principal component factoring, right? Then based on the eigenvalues, then eigenvalues greater than one. Now it's going to uh, take combine based on the eigenvalues, right? Eigenvalues. Then we can continue. Then we can take the out. Now it's now it is, yeah. So then if we consider here, right, it is actually quite similar. But now SPSS has had the freedom to take together these variables, right, like this, right. And when we come to the factor matrix, you can see squaring the load of the summing gives either the cumulative of your extraction sum of the squared loadings, right? Here, sum of the square loading is 3.01. If we add this all, then here, if we add this again, we can take the same value 3.01. Now you can see here, right? So there, this is divided into two, right? Two variables. That how its two variable is decided? It is decided by the SPSS using the eigenvalues, not we divided. Okay. So then here you can see there are two factors actually. Here it is divided into two. You can see factor one, factor two. based on the eigenvalue. Two factors extracted after 79 iterations using the principal access factoring. Because we give the command to the SPSS using the eigenvalue, divide these items into two factors. So SPSS did it using the statistical analysis, not we do not deciding so which are connected. So then you can find these connected items. One is SPSS anxiety, the other one is tech anxiety, right? That is the uh, two factors actually. So you can see here, this is 0.59 SPSS anxiety. So these values, that is factor 1, 0.59, 0.23, 0.57. So these are the factor loadings. And if we consider the tech anxiety, the loadings are there. It is, you can see here, see negative 0.12, negative 0.51. Likewise, we have these factor loadings. Therefore, uh, so we divided this one uh, questionnaire into two factors. One is SPSS anxiety, the other one is tech anxiety by using this factor analysis. Right. So then we can go for uh, some rotation methods, right? Like maximal likelihood extirpation. So I will explain that only to you. Otherwise, you may feel quite complex because there are many methods. At your level, I think it's enough to take one or two methods to do the fact analysis, right? Then next one is analyze dimension reduction fact analysis. Again, we can check the method maximum likelihood. We can change. So we can go analyze dimension reduction factor analysis. Uh, now we have to go for the extraction method. Extraction method, maximum likelihood. We can change maximum likelihood. And fixed number of factors here we can mention. Then number of iteration 100, right? All the others are same. We can take the output, right? So iterations. Then you can see here goodness of fit statistics given there. Uh, this testing, we reject the two-factor model actually. So because this is significant, the chi-square value is significant, so we have to reject the two-factor model here. Right. Actually, it's that is enough up to you for the factor analysis. So what you need to remember is that so sometimes, yeah, this is the most important thing, like this one. So if there are many factors, yeah, this one. If there are many items in your question, yeah, so you have to uh, take this together to create the variables, right? To create the variables. For that, so we can do this manually. If we are did it manually using some things, so we have to use the confirmatory factor analysis to verify it. But so if we use exploratory factor analysis like this based on the eigenvalues, so it is automatically it is divided into two groups. So you can see here factor one, factor two. So then we can divide that into two factors using the SPSS. Just we need to give the command. I need to do the factor analysis and extract the factors. So then SPSS automatically did it. Right. So this is the way of actually calculating the validity of a questionnaire. Validity. So the other one is with the validity. Other one is the reliability. It is very easy actually to check the reliability. So in a questionnaire, what you can do is you can go analyze, analyze, scale, reliability analysis, analyze, scale, reliability analysis. So then these are the items, right? These are the items. Then, yeah, we are going to calculate Cronbach alpha value. That is why it's mentioned alpha. Then we can take the output for the reliability. For all variables, there are 2,571 variables here. Then Cronbach alpha value is 0.459. Actually, that is not a very good value because it should be at least greater than 0.7 to be reliable. So now what we can do? It is actually reliability is not good actually. Um, right. So it means there are some unwanted things. It means if we use a questionnaire, because all the participants are not honestly give the answers, right? Sometimes um, we have to change those things, right? So statistics. Then here it's mentioned there is then this is reliability in statistics. So you can see here that SPSS suggested. So how we can improve the reliability. So in here you can see uh, scale of if item is deleted. So what happens to uh, the correlation if items are deleted? We have to remove some items actually. So if you remove some items, it means some questions from the questionnaire, so we can improve our reliability. Otherwise, then now this model is we can't use actually because it is not reliable. Then we'll see what happens with that. Then it's given 0.491, and we have to increase for 0. More than 7. Then here you can see yeah mm, Cronbach alpha value. Here you can see we can increase only the maximum value is 0.662. To that, we have to erase this one. What is this? Standard deviation excite me. If you deleted this question, so we can improve our front batch alpha value for 0.662. We'll see it. So it means what is that question? Standard deviation excite me. We'll see standard deviation excite me. This one. So I will erase this one. Clear. Now I erased. Right? Then we'll check the reliability again. Now I deleted. Analysis, scale, reliability analysis. Right? Okay. Now it's now what happens? It increased to 0.662. And if we need to further increase, now again the suggestions are here. Now we can improve this for 0.748. So then it should be greater than 0.7 or so. Then I can improve this for 0.748. What you need to now I have to do, I have to delete this item. My friends will think I am stupid from being able to cope with SPSS. Right. My friends, this one. Second question. Clear. Now I deleted that also. Again, we can check analysis, dimension reduction, sorry, scale, reliability analysis. Okay. Now my reliability is 0.748. Actually, that is the maximum reliability value I have to check. Then now I deleted two items because I wanted to improve my reliability of my questionnaire. Right? If I added all of these 8 items there, so my reliability of the producing answers are not very good. Therefore, that's why I deleted these two. Originally, I prepared the questionnaire with 8 items, but for the reliability purpose, I have to delete two by based on the front batch alpha value. Then final version of my questionnaire had only 6 questions now. Right. So likewise, we have to do the reliability analysis. And here I mentioned that how we can increase our reliability, right? So that these are the things we have to use. Actually, we can use to improve our reliability and the validity. So actually, that is about the um, validity and the reliability. Actually, okay. Actually, that is what I wanted to discuss throughout this course. So if you have any more questions, right, so you can ask. So I think this background information is enough to do the analysis of your research projects, because you know all the parametric methods we discussed, and only one non-parametric technique we discussed, how we can do the chi-square test in your research, because if you have some uh, non-parametric items, I hope you will understand it, because most of you are not available in online. You are using um, the recordings. Uh, Therefore, if you have any problems while you are doing, uh, so you can send that problems to your group, then your coordinator will forward to me, then I can give the answers, right? Okay, so then you can contact me anytime, because if you need help to the analysis, right? Okay, then right, then good luck to you all for your research. Bye.
Thank you, sir. It was very valuable.